Hello everyone, welcome to this lecture. I am Amlan Das. Today I will discuss about superconductivity. Okay, so let's see what is superconductivity. In most metal, if we see the variation of resistance with temperature, that is, if we plot temperature along x-axis and resistance along y-axis, then we will get this type of graph. That is, with decreasing temperature, resistance decreases, but at 0 Kelvin temperature, resistance is not 0. Okay. So, this is the resistance versus temperature graph for most metal, we can see. But there are some metals or alloys for which we can see that with decreasing temperature, resistance decreases, but after a particular temperature, resistance suddenly drops down to 0. Okay. So, for some metals or alloys, we can see that with decreasing temperature, resistance decreases up to a particular temperature, then it abruptly becomes 0. This particular temperature at which resistance becomes 0 is known as critical temperature, and it is denoted as Tc, and this phenomenon is known as superconductivity. Okay. So let's see what is superconductivity. Some metals or alloys exhibit zero resistance or infinite conductivity when cooled to sufficiently low temperature. This phenomenon of disappearance of electrical resistance below critical temperature is known as superconductivity. Now, superconductivity was first discovered by Camalding Ones in 1911. He observed that the resistance of mercury decreases with decreasing temperature, and at 4.2 Kelvin temperature, that is at Tc equals to 4.2 Kelvin, resistance of mercury suddenly drops to 0. Okay. Now, similar results were also shown by various metals like lead, tin, etc. Okay. Now, the temperature at which transition from normal state to superconducting state occurs is called critical temperature or transition temperature, and different metals have different transition temperature. The material is in the normal state above Tc and it is superconducting state below Tc. Okay. Now, in the beginning, when superconductivity was first discovered, it was a curiosity among scientists. But after some time, it becomes most interest because superconductors have zero resistance and it has negligible heat loss, so it can be used to fabricate powerful devices which can consume very little electrical energy. Okay. For example, a superconducting electromagnet can function for years even after cut-off of the supply voltage. But unfortunately, the maintenance of liquid helium temperature is very expensive and difficult. So, efforts were therefore taken to produce superconductors at higher temperature. 70 years later, in 1980, new oxide superconductor with high Tc ceramics whose critical temperature is 125 Kelvin or above was discovered, and it gave a remarkable turn, and new high temperature superconductors was discovered. Okay. Thus we discuss superconductivity. Okay. Thank you for watching this video.